Before we review systems of inequalities, I'm going to go ahead and do number 1 here. So remember, when graphing a linear inequality, you have to identify the slope. In this case, it's -1. And then you have to identify the y-intercept. In this case, it is 1. So what you're going to do is you're going to go to 1, and then we are going to graph the boundary. So we're going to go down 1 over 1. And we're going to continue this until we go across the grid. Now remember, in order for us to know if the boundary is part of the solution, there has to be an equal sign, and we notice that there is an equal sign. So I'm going to go ahead and I'm going to make that a solid line. That means that a solution could be on the boundary. And since it says greater than, y is greater than, we're going to shade above. We did already mention that a solution could be on the boundary. One of the answers is going to be 0, 5. 0, 1, 2, 3, 4, 5. It's actually any point that's in the shaded region. That would be a solution. Number 2, this is not in slope-intercept form, so we're going to have to solve for y. So we have 3x minus 2y is greater than -12. So what we need to do is we need to subtract 3x. We subtract 3x. So we have -2y is greater than. Now this you can't subtract. So it's -3x minus 12. Then we divide by -2. We divide by -2. We divide by -2. And -2 divided by -2 is 1. So you're left with y. Now since we divided by a negative, the inequality is going to change. So it's less than. A negative divided by a negative is positive, so it's 3x over 2. And we have a -12 divided by -2, which is going to be positive 6. So where do students make mistakes? It's on the inequality sign. And if you notice, it goes from greater than to less than. So we're going to go ahead and identify the slope. In this case, it's 3 over 2. And then we're going to identify the y-intercept, which is 6. So go ahead and go up 6 units. 1, 2, 3, 4, 5, 6. Put your point. Go up 3, 1, 2, 3 over 2. You can also go down 3, 1, 2, 3 over 2. Go down 3, 1, 2, 3 over 2. And then continue this. And since an answer cannot be on the boundary, then we have an open boundary. And we're going to shade, since it's less than, we're going to shade below. So there's our answer, and our shaded region is going to be a solution area. So 0, 0 is an example of a solution point. It'd be any point that's in the shaded region. So now we don't have just one inequality, we have two inequalities. So it says solve the system of inequalities by graphing. So we know that this equation, this inequality has a y-intercept of -2. And has a slope of 1. So I'm going to go ahead and graph that. You might be wondering, how am I coming up with these points? Do you remember that the slope is up 1 over 1? And we notice that there is no equal sign, so the boundary has to be broken. Now it says here y is less than, so I'm going to use a different color. I'm going to use yellow. And so there's the first inequality. And now I'm going to graph the second inequality. So I'm going to go up 5 units. 1, 2, 3, 4, 5. I'm going to go down 2 over 1. Go down 2 over 1. And then I'm going to repeat that process. And you notice that there is an equal sign. So the answer can be on the border. And it says y is greater than or equal to -2x plus 5. So what I'm going to do is I'm going to use a different color. And you'll notice that the two colors do intersect. And where the two colors intersect, that will be the solution. So this right here is the solution area. So if you ask yourself, what is a solution? Well, it's any point where the two colors intersect. So I'm going to go ahead and start at the origin. 1, 2, 3, 4, 5, 6. So I just randomly picked 6, 0. So a non-solution point would be anything outside that area. So we can always select 0, 0, and it's right here. It's the origin. So you see that it's not in the shaded part, the two shaded parts. Now, there might be inequalities that are not already solved for y. You might have to solve, so I'm going to go ahead and do 3x minus 3y is less than or equal to 12. So I'm going to solve for y. I subtract 3x from both sides. So you have negative 3y is less than or equal to negative 3x plus 12. And then we divide by negative 3. And just like I said before, if you divide by negative 3, we have to change the inequality. So you have y is greater than or equal to x, since that's 1, minus 4. Now I'm going to go ahead and solve the other inequality. We have x plus 2y is greater than 3. I'm going to subtract x from both sides. So you have 2y is greater than negative x plus 3. And then the final step would be to divide. And I'm going to go ahead and write the inequality right below it. We have y is greater than negative x over 2 plus 3 over 2. Okay, so let me graph the first one. So we have a y-intercept of negative 4. 1, 2, 3, 4. That's negative 4. We go up 1 over 1, and I'm just going to repeat the process here. And it is a solid line. So now I'm going to shade. I'm going to shade above. Okay, the other one is 1.5 is the y-intercept. So 1.5 is right here. I'm going to go down 1 over 2. Go down 1 over 2. And now it's going to be a broken boundary since there's no equal sign. And I'm going to shade, and I'm going to use a different color. And where the two colors intersect or overlap is going to be our answer. And you know it's going to be in that darker pink area. So any answer that is here, even if it's right here, is part of the solution right here. So this is 1, 2, 3, 1, 2, 3, 4, 5. So the solution point is 3, 5. A non-solution point would be anything that's outside of that area. So I'll just pick a point here. So that's 0, 0. Here are some outcomes. We can have two that are going in either direction. And of course, they will not overlap. We can have something like this where the answer is between two parallel lines, or it can be like this. Also, we have these two lines here and the areas where it's overlapping. So these are three possible answers. I'm not going to do too many examples on your homework. I'm just going to do one. So you first got to make sure that both of them are solved for y, and of course you know the first one is not. So I have x plus 2y is less than or equal to 8. So I'm going to go ahead and subtract x. I'm going to subtract x. So I have 2y, that's 0, less than or equal to negative x plus 8. And then what I'm going to do next is divide by 2. So we have y is less than or equal to negative x over 2 plus 4. Okay, and yeah, I put it in slope-intercept form, but it's an inequality. So now what I'm going to do is I'm going to go up 4 units. 1, 2, 3, 4. I'm going to go down 1 over 2, down 1 over 2, down 1 over 2, and I'm going to go up 1 over 2, up 1 over 2. So I'm going to go ahead and connect, and you notice that the boundary is solid. The other inequality, y is less than or equal to x plus 4, is already solved for y. So I'm going to go ahead and use a different color so we can see the difference. And the y-intercept is 4, 1, 2, 3, 4. I'm going to go up 1 over 1 and just follow that pattern. And the boundary is solid. Now what I did forget was to do the shading. I'm going to use green for the first one. It's less than, so I'm going to shade down. It's less than. And then the other one, I'm going to use red, and it's going to be shading also down. So it's shaded down. So you can see where the two colors overlap. So we notice that 0, 0 is in the solution area. So we have 0, 0. And the non-solution area, it has to be just outside. So it could be either here, it could be here, it can also be here. So I'll just say point A, point B, point C. This is your solution, okay? So you can pick any of those letters or any of those points So I'm going to go ahead and pick B, 0, 1, 2, 3, 4, 5, 6, 7, 8, 0, 8. We're going to solve a system of 3 equations and 3 unknowns, and we're going to use what we call matrices, okay? So if you can focus your attention on this side, I'm going to show you one method. It's called the row reduce echelon form. The short name is RREF, so it's called row reduce echelon form. What you need to do is, if you're going to solve this system, first of all, it has to be in standard form. That means you have X, you have Y, and you have Z on one side. Okay. Now, to type in this matrix, and you're probably wondering what are these numbers represent. They actually represent the coefficients. So go ahead and go to desmos.com/matrix, type in the new matrix, and you notice that we have 1, 2, 3 rows. So we have 3 rows and then 4 columns. Now you notice that the first coefficient is 1, so you type in 1. You notice that the second coefficient is 2, so you type in 2. And you notice that the third coefficient is 1. And then the last number is 9. 9 represents the answer for this equation. Okay. The next row, we have 2, and then we have 1. Now you probably wondering, how did you get 2? 2 is up here. You see that 2? And then you have a 1 right there. The next one is 3, and then you have a 0. So that's the next row. And then the third row, you have 3. You have -4. Yep, negatives, you need to be careful if you have negatives. And then the next one is -5. And then the last number is 1. Now, a warning for everybody. If you don't type this in correctly, in other words, the coefficients, and it has to be in standard form, you're going to get the wrong answer. So I'm going to go ahead and press enter. So now my matrix is in the calculator. I'm going to do row reduce echelon form, and all you have to do is type in the matrix. Now you notice that you get this diagonal. That's what you want. So the first one is X. So they're saying that X equals 2. The next one is Y equals 5. And then Z equals -3. And if you see at the bottom of the page, that is the answer that you have. You have 2, 5, and -3. What I'm going to do is I'm going to go ahead and give you some examples through your homework here. I'll probably do maybe 2, and then we'll go to some application problems after this. Okay. So here we have a system, and we do have 3 equations, but we don't have it in standard form. So this 2z, I will have to subtract 2z. So I'm going to write x plus 2y minus 2z equals -7. So that's my first equation. My second equation, you notice that 3x is on the right side. So what I'm going to do is I'm going to subtract 3x, and then you have 4z. You have 4z equals, and you're left with 1. Next, we have y, so I'm going to go ahead and write y. And then we have z, and z has to be on the left side, so I have to subtract z, and then this is equal to 6. Now, I do want you to notice something. I have some gaps here. Now, these gaps represent the coefficients for the y value here. So, to make your life easier, just write plus 0y. And over here, you see how we have a gap for the x? Then what you want to do is you're going to write 0x. Okay. Next, we're going to write the matrix. So the matrix looks like this. It's a bracket. Now, all you have to do is list the coefficients. And if this helps you, you can write a 1 here, you can write a 1 here, you can write a 1 here. So you got to be accurate. So you have 1, 2, -2, -7. And then you're going to list -3, 0, 4, and then 1. And then the last equation, you have 0, 1, -1, 6, close the bracket. The next step is to go to your matrix calculator. Now what I'm going to do is I'm going to clear it. I'm going to clear all because I'm writing a new matrix. You have to write down the number of rows. These going from left to right are called rows. So you have 3 rows, and the vertical numbers are the columns. So you have 4 columns. And then make sure that you're accurate. So it's going to be 1, 2, -2, -7. Okay, the next one is going to be -3, 0, 4, and then 1. And then we have our last row, which is 0, 1, -1, 6. Okay, so now what you're going to do is you're going to go ahead and type enter or the backslash. So that matrix is in the calculator. You're going to go ahead and select RREF, and you're going to type in the matrix. So the matrix is just A. And here is your answer. So you're going to go ahead and you're going to have 1, 0, 0, -19. The next one is 0, 1, 0, -8. And then the last row is 0, 0, 1, -14. So what does this mean? That means that X is -19, Y is -8, and Z is -14. So that's the answer to this system. Once again, we're solving the system, but we got to make sure it's in standard form. So you have X plus 2Y minus 2Z equals -7. Now the next equation, we have 4Z equals 3Y plus 1. And you notice we don't have an X, so it's 0X. If I move the 3Y to the left, it's going to be minus 3Y. I already have 4Z equals 1. Now, the last one, we have an X. We don't have Y, so we're going to say plus 0Y. Z is on the left, so it's going to be minus Z. And of course, a constant, which is the number 6, it's going to go to the right, so it's -6. So now we're going to go ahead and write it in an augmented matrix. So remember, it's a bracket. So if it makes it easier, you could go ahead and put your numbers there. So don't forget the negatives. So you have 1, 2, -2, -7, 0, -3, 4, 1, 1, 0, -12, -6. Okay, so let's go ahead and type that into the calculator. So I'm going to clear everything. I'm going to clear all. So I'm going to press A, new matrix. So I'm going to go ahead and have 3 rows, 4 columns. Make sure that you're accurate. We are typing in the coefficients. So it's 1, 2, -2, -7. The next one is 0, -3, 4, and then 1. And of course, the last one is 1, 0, -12, -6. Now, you're going to go to the RREF, type in A. Now, if you get something like this, you can always, you see it says convert to a fraction. And if that fraction is better, then that's fine. But I got to make sure that I have the right numbers here. So I have 1, 2, -2, and -7. And then I have 0, -3, 4, and then 1, 1, 0. There's my mistake. I put a 12 instead of just having -1. So that is my answer. See how I made a mistake? It should have been -1. I put 12. I don't know why I put 12. So little mistakes like that will cause you to get the wrong matrix. So X will be -31/5. Y will be -3/5. And then Z will be -1/5. So it's parentheses, -31/5, comma, -3/5, comma, -1/5. Okay. The sum of 3 numbers is -2. So X plus Y plus Z equals -2. The sum of 3 times the first number, so it's 3x, twice the second number, 2y, and the third number, so it's z, is equal to 9. The difference between the second, which is y, minus half the third, 1/2 z, is 10. So now we're going to write our matrix. So it's 1, 1, 1, negative 2, 3, 2, 1, 9, 0, 1, negative 1/2, and 10. So now you're going to go ahead and write it into the matrix. So I'm going to clear it. I'm going to clear all. And here's our matrix. It's 3 rows, 4 columns. So I have 1, 1, 1, negative 2. Make sure you're accurate. 3, 2, 1, 9, 0, 1, negative 1/2, and then 10. I'm going to go ahead and press enter. I'm going to go ahead and type in RREF, type in A. And so here are my numbers. We have 1, which is X. X is what number? It's 3. Y is 5. And Z is negative 10. So the numbers are 3, 5, and negative 10. I'm doing the review. I'm going to be doing the odd numbers. So I have determined the domain and range of the following function. So remember, domain is the X value, and we know that the lowest is a negative 5. We know the lowest is negative 5. We know the highest is 6. So X is less than or equal to 6, and it's also greater than or equal to negative 5. The range, we have to look at the lowest Y value. In this case, it is negative 6. And then we have to look at the highest Y value, which is 7. So we have Y is less than or equal to 7. Y is greater than or equal to negative 6. Number 3, it says given f of x equals x squared minus 8x plus 3. So we have f of 2 equals 2 squared minus 8 times 2 plus 3. So we have 2 squared, which is 4, minus 16 plus 3. So it's 7 minus 16, which gives you negative 9. So f of 2 gives you negative 9. Once again, you could have used your Desmos, or I know some of you just have Desmos, so I'm going to use Desmos for this review. So I have f of x. So I'm going to type in f of x equals x squared minus 8x plus 3. And look what Desmos can do. You can even do this. F of 2. And you see how we get negative 9? So f of 2 gives you negative 9. Number 5, we have g of x minus h of x. So you have 8x plus 5 minus parentheses negative 3x squared plus 8x. So what you have to do is you have to distribute the negative. So you have 8x plus 5, and it's going to be a positive 3x squared, and then a negative times negative times positive negative 8x. I'm kind of running out of room, so I'm going to try to put it here. So you got to write this in standard form. So the highest exponent is 2, so you have 3x squared. 3x squared. You have 8x minus 8x, that's 0. And then it's going to be plus 5. So this is your answer, or your simplified operation. Okay. Number 7, we have h composition of g of x. So you have h composition of 4x. So the input is 4x. So what you're going to have, input squared plus 2 times the input. So the 4x will have to go in as an input, and 4x here has to go as an input. So 4x times 4x is 16x squared. And then the product of 2 and 4x gives you 8x. So you have 16x squared plus 8. Number 9, we're going to solve this absolute value equation. You first have to subtract 2 from both sides. Remember that you want to have the absolute value. So you have 6 absolute value b minus 8 equals 54. The next step is to divide by 6. So you have the absolute value b minus 8 equals 9. Now you will have two equations, b minus 8 equals 9. B minus 8 equals negative 9. So B will have to be 17. And B equals, you add 8 to both sides, it's going to be negative 1. So remember, you always want to check. So here is the calculator here. Using Desmos, it's going to be 2 plus the absolute value, 17 minus 8, and I'm missing 6, and I did get 56. So now you want to check out negative 1. So I'm just going to change it here, and I'm going to type in negative 1, and do I get 56? Yes. So both answers are true. Number 11 is solving an absolute value inequality. So once again, we have to have the absolute value by itself. So we add 8 to both sides. So 17 plus 8 gives you 25. And you notice we have the absolute value by itself. That's what we want. So we have 2v plus 7 is greater than 25. And then you have 2v plus 7 is less than negative 25. So you have two absolute values. You subtract 7 from both sides. So it's 18. 25 minus 7 is 18. Divide by 2. So v is greater than 9. So this is 0. This is 9. Open circle. Greater than 9. We have 10, 11. So it goes in this direction. Okay, we're going to subtract 7. Subtract 7. So we have 2v is less than. Negative 25 minus 7 is negative 32. So v is less than negative 16. So you come over here to negative 16. Of course, it's not written to scale, and you're gonna shade to the right. So the answer is all the numbers that are less than negative 16 or all the numbers that are greater than 9. It says here, solve the following system of equations. So here is the system, and I'm going to solve by graphing. So we have to write it in slope-intercept form. So we have to solve for y. So you have 8y equals 12x plus 20. That means I have to add 12x to both sides. And then I divide by 8. So we have y is equal to, now we have 12 over 8. Both of them are divisible by 4, so it's going to be 3x over 4. 20 divided by 8, each of them are divisible by 4 again, so you're going to have 5 over 2. And if you want to already type it into Desmos, you can. So we're going to type in the equation y equals 3x over 4 plus 5 divided by 2. Okay, so we're not quite done yet. So we have 3x minus 2y equals negative 5. So I'm going to go ahead and solve for y. So we subtract 3x, we subtract 3x. So you have negative 2y equals negative 3x minus 5. Divide by negative 2, divide by negative 2, divide by negative 2. So y equals 3x over 2. And you know what? 12 divided by 4 is 3. 8 divided by 4 is 2. I made a mistake here. That's 2. So this equation, I needed to correct it. And this one, so both equations are the same. So that means they coincide. So that means there are many, many answers. Okay, so they're actually the same line. So for 16, I'm going to find the inverse. So first I'm going to write y equals 1/4 x minus 13. And with the y and x, we're going to switch. So we have x equals 1/4 y minus 13. Now we need to solve for y. So you add 13 to both sides. So you get x plus 13 equals 1/4 y. And we know that the negative 13s cancel. Then we multiply times 4. You multiply times 4. These cancel. So you have y equals 4x plus the product of 13 and 4. It's 12. Raise the 1. So it's 52. So the inverse is 4x plus 52. And the function is 1/4 x minus 13. Now, if you want to check if they're both inverse, you just have to look at the table. So I have y equals 4x plus 52, and I have 1/4 y equals 1/4 x minus 13. Look at your tables. So if I were to say, if I were to type in 44 here, I get -2 back. You see that? If I type in 48, I get -1. If I type in 52, I get 0. If I type in 56, I get 1. If I type in 60, I get 2. So it does check. Number 19, we have a parent function. We know that it's going to shift to the left. So the vertex will be -9, comma. We know it goes down, so it's -5. We know that the axis of symmetry is x equals -9. The transformation, vertical stretch by 2. It's going to shift left by 9, and it's going to shift down by 5. So it's going to be a vertical stretch. It's going to shift left by 9 units, and it's going to shift down. Now you can also see this in Desmos when you're at home studying. You can just actually type it in here. So I have f of x. By the way, you can even just type in f of x equals 2 absolute value x plus 9 minus 5. Let me make it bigger. Here's the parent function. And you notice it goes to the left and it goes down, and the vertex is -9, -5. Like I said, the axis of symmetry is x equals -9. You see that line that goes right through it. And so it is correct. Number 21, solve the system of inequalities by graphing. So you go to the y-intercept here, which is -2. Go down 1 over 1. And you can repeat that process, connect the points. The boundary is solid because it's equal to. We're going to go ahead and shade up. Now we're going to go ahead and and graph the second inequality. So you're going to go, the y-intercept is -3. It's the green one. I'm going to go up 1 over 2, go up 1 over 2, connect the points. So this is the green one. And now we will shade down. And do you see where both intersect? That will be the answer to the system. Write the matrix as a system of equations. Just remember that this is your x value, this is your y value, and this is the constant or the answer. So we have -2x plus 9y equals -11. That's one equation. The second equation is -15x plus 6y equals. So that's in the matrix as a system. 25, the table below defines a function, h of x. What is the value of the inverse of -10? So if you want the inverse, remember that we have to switch the x and the y. So we're not looking at the x, we're actually looking at the y. We look at the y. And if you want to do the inverse here, I would probably, what I would suggest you do, make a table, and this is the inverse. So what I have to do with the x and the y, you just have to switch. So it's 5, -10, 2, -1, -4, 3, -7, 5, -10, 7. So now, what is the inverse of -10? Well, it's 7. Just by looking at this table, -10. 26, explain why f of x and g of x are inverse. Remember that the table, the x and the y value will have to switch. So in your paragraph, I would write something that the x and the y value tables have switched. Also, what I would recommend that you do is go ahead and do the mirror. Remember, we talked about the mirroring class, and the mirror is an actual characteristic of two equations that are inverse of each other. So one, I would probably talk about the table, then I would talk about the mirror, and then just further explain why they're both inverse of each other.